Hi guys, welcome back to Recitation. So this week we will cover the material from Unit 2-1. So basically what we will cover is the programming exercise 2-1 and lab 2-1. So let's just get right to it because it's gonna be short this week, I hope, because these are fairly simple, but there's some good things that you should be mindful of. And most importantly, the first thing I just want to say is in the book, there's in the book, uh, there's one bit that says in chapter 5 actually, and 6, one of them has a section called the function of functions. So please read that part. It's essential that you understand why you would use a function in the paradigm of Python, right? Okay. So let's just begin. So the first thing we're going to look at is the programming exercise 2-1. The problem statement is fairly simple. So a CS professor gives out a 100-point exam, and these are the grading scales that he uses. So 90 to 100 is A, and 80 to 89, these ranges are B, 70 to 79 is C, so on and so forth. Now we want to write a function called grade that accepts the exam score, meaning something between 0 to 100 inclusive, as an integer, and then it will return a single character. All right, so we will send a number, and in return we want a character back, and that's all that we have to do in this function. So, and it doesn't have to print anything, it doesn't have to do anything yet, but I'll show you how to test this, okay? All right. So now, before beginning, actually before writing the code, if you have thought about this problem, then the first thing might be, or if you have read a little bit ahead, then you'd be tempted to use conditionals like if, else, etc. But we haven't covered that, so we have to approach this problem having those tools aside. All right, so we will do it without using if, else, and stuff like that. So we will use math. Math essentially solves most problems in life. Okay, so if you've thought about the technique, and this has been quite uh, popularly propagated from us to the students on Piazza by everyone. And there was also a post on Piazza, if you've noticed, in the FAQ section about like some hints about the mathematics of it, like how we can, given a number in this range between 0 to 100, we can scale it back down to 1 to 10, which will essentially be a list where we will store the grades, meaning the numbers will correspond to the indices, whereas the actual value in the list will be the grades. So A, B, C, D, and F. There's no E. It's interesting. It makes me wonder like why there's no E anywhere. And not only here, but in actual schools. So let's just jump into code. And as always, we will start with pseudocode, which is always the best idea. Okay. So I have already jotted down some bits and parts of it. So we have the header that everyone should have. That's just the generic name. And now with all the introductions, we will first define the grade function, which accepts the exam score as an integer. Okay, let me first go through the whole pseudocode and then we will go step by step. Then we will create a list for each letter grade. Okay, so we will see when we do that. And then we will calculate a single letter grade using integer division. These whole ideas were all discussed actually on Piazza. Okay, and then finally we will return the determined single letter grade like A, B, C, and so forth. So, okay, so let's start, and once we start working through it, it'll become much clearer. Okay, first we will define the function that accepts. This accepts part is new last week. So the way you used to define the main function before in the older assignments, that was like def main, and you do parentheses and you write your code. But inside the parentheses, we didn't put anything before. But this time around, we are going to put something inside, and that is the thing that we are going to send to the function, and meaning that's something that the function will accept. And the thing we are going to send is going to be called score. You can name it whatever you want to, but I'll be calling it score. Now, the score, well, think about it. The score is it can be 100 at max and 0 at minimum. All right? Okay. So just for clarification, let me just write it out. Okay. Now we will create a list for each letter grade, but there's a reason for this. The reason we'll do that is actually in the next step, which is we will calculate a single letter grade using integer division. Now the thing is, before going to a single letter grade, so that are A, B, C, D, and F, let's go to a single number, all right? So right now we have a number that is out in the scale of 100. Let's say we want to scale it down to 10. So to get that number, so number, we can do score, and then we can do integer division 10. Now, what is integer division? That's another question. So integer division, or also known as floor division, is a division where you use 2 slashes instead of 1 in Python. And the output is something like whatever you get is never a fraction. It's always a whole number. For instance, we know that 4 divided by 2 is basically 2, right? Okay. But we also know that 5 divided by 2 is 2.5. Now the thing is, if we had done integer division, then 5 integer division 2 would be actually just 2. Not 2.5, but 2. Another example can be like, let's say you divide some number by some another number, and it comes out to be like, let's say 8.9, just assuming. So but that was for regular division. But if it was integer division, then it would be rounded to not 9, but the thing below that. So only 8. All right. So the the basic logic for this, for doing this, is so that if you have 100, the 100 will become a 10, right? And a 90 will become a... Okay, so that was integer division, and I hope that makes sense, because again, just to repeat, if we have 100, we want to scale it down to 10. If it's 90, we want to scale it down to 9. If it's a, let's say 95, let's say you got 95 in an exam, then we want to scale it down to 9 actually. So if we do that, oops, sorry, that was something else, a map that I was working on. Anyway, so if it's a 95, we don't want it to come out as 9.5. We don't want that. We want 9 because we want whole numbers to index characters in a list. So the key thing here is the fact that indices can only be whole numbers. So now that we know that we can index, we can transform the scores into some indices, let's make that list that holds those grades, the letter grades. So let's say you got 100, and then you want now the letter grade that you expect out of this range is actually an A. So we want A to be at index, or we can call it at place, at index or location 10, right? Because 100 integer division 10 is 10. And now let's say you got a 90 and we had done integer division on that. Then 90 integer division 10 would give you 9. And what grade would 90 give you? 90 would give you also an A. So we can actually plug in A twice. Okay, so the way this would work would be, let's say we have a list, and at location 10 we want to have A. At location 9, meaning what 90 will turn out to be, would also be A. And I need to make a point here that if you got, let's say, 93, it's not going to be scaled to 9.3. It's going to be scaled to 90. So anything between 90 and 100 will be either 9, or if it's 100, then it will be 10. Okay, so that's why think of this location as location 10, this location as location 9. And that's why we are going like from the end to the beginning, right? Okay, and then from 80 we have B, from 60 we have C. Okay, then we have D. From 6, oh sorry, from 70 we have C, and from 60 we have D. Now after D, what we have is F, but the thing is, F has a bigger range. Notice that 0 to 59 is F. Okay, so that will take up multiple places in our list. So we can actually do this, this. Okay, let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, not 9. We need one more. We want to have 10 of these guys. Okay, so this list, now let me write this right below it so that it makes more sense. That this first F is for 0 to 9. The next bit is for 10 to 19. The third index, so this is index 0, this is index 1, this is index 2. So index 2 would be in the range of 2 to 29. Index 4, 0, 1, 2, 3, sorry, index 3 will be 30 to 39. and then 40 to 49, 50 to 59, 60 to 69, 70 to 79, 82, oops, 80 to 89, 90 to 99, and then we have 100. So if you look at the indices, so this are corresponding to list location 0, then 10 to 19 corresponds to list location 1, the 20 to 29 corresponds to list location 2, 30 to 39 is list location 3, so 40 to 49 is list location 4, 50 to 59 is 5, then 60 to 69 is list location or list index 6, 70 to 79 list index 7, 80 to 89 is list index 8, 90 to 99 is list index 9, and then for 100 we have list index 10. So you see how the way we transformed it is actually the number is going to be scaled down to either 0 or 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. And then from that, using the list, we are going to use that number to index, to get, and use the index to retrieve these alphabets, these letters, right? Okay. So in order to do that, we are going to return the determined thing, letter grade. So the next step would be return L. So because L is the list of all the letter grades, so L of the, what is the integer that we want, the index that we want to have, which is number. And that should do the trick for us. Let's just bring, okay, but before taking it for a test run, let's do something else. Not something else, let's structure this well, because we don't have a main function, and you don't need to have a main function for getting full credit on this lab, but we're just gonna still make one to test this out, okay? So let's do def main, and inside the main function, let's just call the function that we just created, the create function. So we can print out the value, like let's say grade, and let's say you got 100, which is, well, everyone wants that. Then let's do print, and let's use a test value of, let's say, 95. So we'll try to get good grades. Okay. And then let's do print grade, let's say 77. So what we're expecting is to get an A here. We're expecting to get an A here as well. And over here, we are expecting to get a C. Is it? Yep. Okay. So, but let's just top it off with another A. Okay. Now, let's go ahead and run it. Okay. Okay. Some technical issues, but let's rerun it. Okay. Well, one thing we missed was we made the main function, but we never called it. We need to call the main function. Let's go ahead and do that. So let's do a call to me. All right, now that should be a breeze. Save it. Okay, and we see A, C, A. So this was for the 100. This is for the 90 something. This is for the 77, and this is for the 99, I guess. So it works, and you'd get like full points for this. However, let's do a second version of this. Let's just change a little bit. So you might be wondering, like, okay, so we have 1, 2, 3, 4, 5 grades, but why do we need to have all these like 10 things? And more scary is, why do we have so many Fs? Like, we don't want to get Fs. We want to get like good grades, like A's and stuff. So as an alternative, what we can do is, let's just copy this part so that we don't like repeat this. So we can actually play around with the list a bit and do some clever math. Indentation going haywire. That's okay. Let's paste it. Okay. Let's correct this. Okay, now you see that we only have A twice and other things once. We will need the two A's because we have to handle the 100 out of 100 situation. If you think about it, you'll know like 100 with divided 10 would give us 10. So now the thing is, this time around, L, actually the list L does not have 10 indices. It has only 6, right? Okay, okay. We can deal with that. Now, how can we deal with that? Instead of having just dividing it by integer division 10, which will give you, which gives us a number between 0 and 10, inclusive, meaning 0 and 10 are included. How about we do some extra work and just subtract 5 from that. So anything that was 10 will now be 5. Anything that was 9 is now going to be 4. Anything that was used to be 7 is now 2. Anything that used to be 5 is now 0. Okay? All right. And the indices just simply will work out. So that's a second version of this. So we can just call it V2. Okay. If I'm not wrong, there is a tiny issue in our indentation, which is going to yell at us. But now I just fixed it. Now, if we run this and we get the same result as before, that means that everything's working fine. Okay, cool. Let's run it. So just like before AACA, so we get AACA. So those were two ways of getting this done. And I just want to point out that there can be several other ways you can like cleverly do some mathematics over here and still end up with the right answer. All right, cool. With that said, that was programming exercise 2-1. Great, so let's move on to the next part. All right, now with lab 2-1, in your handbook, in many cases you'll see a line something like, before you begin, carefully review some chapter numbers. When it says that, please go ahead and do so, right? Because that does make sense for you to do it, because anything and everything that you'll do would come from those chapters or anything before that we have learned. So nothing from the future is gonna come, and you won't have to actually figure anything out that has not been taught yet. Okay, now let's just go ahead and go through the problem that we can review. And the ASCII table, as you know, every character that we know have an numeric value in computer science, so which we call the ASCII value. So it ranges from 32 to 127. Then there are 96 possibilities. So just to make a small brief separate point, a capital A and a small a are different numbers to the computer. So anyway, so we would like to encrypt a string like a word or multiple words for that matter. And then we are going to want to encrypt it. So in the encryption algorithm is something like this. Step one, we start with its ASCII value, like for every character. We subtract 32. We add an encryption key called offset. We will call it key for our understanding today. Then we're going to determine the remainder of that number, what we got in step 3, by dividing by 96. Then we will add 32 to the remainder. And then we're going to convert back that number to a character. So we actually have seen something similar in one of our previous labs. To be more specific, 1-3. 1-3. Okay. So now, one fun bit about this algorithm is that if you get an encrypted string and then you encrypt it again, but this time you use the negative offset or key value, then you will get back the string that you had initially inputted. So that's sort of the decryption algorithm. We will see that in action in just a little bit. Okay, so as it was pointed out in the handbook, that's part 1 is to set up your file, which I actually have already. And part 2 is organize it using comments and basically write out your pseudocode, like how your thought process is going. And a very major part of it was actually given in the handbook. So always take advantage of that. Now, these 2 steps seemingly might they may seem simple and they don't seem too much code-ish, but these are essential, because if you do these 2 right, especially the part 2, then the coding part will become a breeze, right? Okay, so now part 3 is the encrypt function. So we will write a function called encrypt, which will accept 2 arguments, so 2 things. If you recall, we accepted one thing in the programming exercise, which was the number of the grade that we were calculating, but this time we will accept 2 arguments, a message called string and a message string and an offset integer. So these are the types of things that we are going to get. And we're going to return an encrypted string. And how we're going to encrypt it, it's based on the algorithm I just showed you here. Okay. So now the setup will be like this, and this is simply copied from the handbook. So you have this available to you. So we will initialize a new empty string, which will be used to store the encrypted characters. Then we will define a for loop that goes through each character of that string as a sequence. And then for each character, we are going to apply that algorithm, meaning this. Okay? And once we are done with each character of the string, we will plug it into the new string that we just initialized, the empty one initially. And finally, once we are done with the string, we will return it back. All right, so let's go ahead and code it. So this is what we have in our coding window set up for you, and there's nothing too exciting yet, but I'm gonna turn on the line numbers. Let's maximize this. We have the comments, the headers. Now we will first define the encrypt function. Then we will initialize any variable that we need, which was actually given to us in the handbook. Then we'll set up a for loop using the characters in the message. I'm calling it message. And then we have made a loop. Now you can use a loop like this that goes on for the length of the string, but I'll show you a better way of doing this. Now, inside the loop, we will encrypt each character in the message using the encryption algorithm, which for brevity's purposes, I actually have it written down, meaning we will take the numeric value of the character, subtract 32 from it, add the key, take the remainder by dividing 96, and then we're going to add back 32. Okay. And then the next step would be to add the encrypted character to the new string. So we're going to plug it back to the new string. And once all the characters have been processed or encrypted, we will return it. And we have set up a main function where we will test this out. All right. In fact, the main function is also part of the requirements. So we will go ahead and see how to do that. But let's deal with the encrypt function at first. So we'll first define the encrypt function, which I have. So def encrypt, and it accepts two things, remember. So one is the string message, and the one is the offset, which I am calling key. Okay. All right. So now the first thing is to initialize some variable. Now, what's a good idea to initialize? So if you look at the pseudocode given in the handbook, it says that initialize a new empty string. So let's call that secret, just because this is a secret message. So the way we do this is that is an empty string. There's two double quotes, and that's it. You're done. Now, a confusion that was that we observed on Piazza is the scope of variable understanding. So this means that at this point, this function can see only three variables. Three. One is the message, the one that was sent to it. One is the number key, and the another one is the one we just made, or as many as we want to make. Those will be available to this. Nothing outside of this is yet available to this function. It knows only three things: the message, the key, and this string called secret. Okay. Now the next step is to set up a for loop using the characters in the message. So one way is the one that I have commented over there, but that's not exactly the right, that's one of the right ways, but the more refined way is to define a for loop using the characters in the message string as a sequence. And the way you can do that is we can do it like this. For, let's call the character X in simply the string that we want to iterate through. So for X in message, do whatever, meaning do the loop stuff. So these X is a single character every time in the loop, in every iteration. So now what we want to do is the encrypt So we already have done this, this is a finer way, and this is the finer way that I'm showing. So we want to encrypt each character in the message using the encryption algorithm. So the encryption algorithm was written out here. So now I'm calling that temporarily as an A. So remember, if you remember that we used this in one of our older labs to convert the character to the ASCII value of the character. So it converts a letter to a number to the ASCII value of that. But what character are we talking about here? What variable is that in our situation right now? So for every step of the message, each of these characters in every iteration is being called X. So let's say that we want the numeric value of X, subtract 32, add the offset key, take the remainder of by divide 96 and 32. Just to recap, so we are doing exactly this. We're starting with the character's ASCII value, which is this, subtract 32, this, add the encryption key offset, we're calling it key, so we're doing this, determine the remainder after dividing by 96, which is %96. If you didn't know that this is the operator for getting remainder, this is the time to like review that. And finally, add 32 to the remainder. But the problem is, there's a little problem here. This whole thing is going to give you a number, but we don't want a number to be returned for each character. We want another character encoded. So what we do is the reverse of what ORD does, which takes a character and gives you back a number. So the reverse of that is to take a number and give you back a character value of the ASCII table. And that is accomplished using the CHR, meaning character function. And that's exactly what we did. And we are storing that encrypted character in the one with where I'm calling it B. Now, since one letter is done, we're simply going to plug it in to the empty string that we had made. I call it secret, so we will do secret and we will add B. Okay, because that was the one we had. So now this secret, after the whole loop runs, is going to end up being our encrypted message. Okay, all right. Now the next step is to return the new string containing the encrypted message. Make sure your indentation is right because we don't want to do this inside the for loop. So we will simply return secret. Okay. And that's it. The function is done. Now that was part 3. Now let's move to part 4, which is the main function. So in the main function, what we will do is we are going to display the description of the program's function and purpose, which we always do. Is always a good idea. Prompt the user for the original message string. We will do that. And to do that, and then we will call the encrypt function, provide the string that the user inputted, the one we want to encode, we want to make secret, and the integer, meaning the key or the offset. Now, we have to remember to assign the returned string value to a variable, or else we are going to lose that value, and then display the encrypted message. So this is what it would look like. So hello world with encryption key 10 would give us this weird sequence. All right. Now let's go ahead and do that. Let's make the main function. I have most of it written down. So the pseudocode will go like, we'll define the main function, we'll display the description of the function's purpose, and then we will prompt the user for the input, and then and the encryption key, and then we'll format it the way it was formatted. It's expected to be formatted like these many header lines, borders. And then we will call that function, assign it to a specific string, and then we want to print the one out. Now, there's a reason. Now, let's go through this, and I'm going to explain everything. So, in the main function, we're going to display the description. So, you already have learned a lot about printing stuff. So, we just print it. And step 2 is to prompt the user for the original message and the encryption offset. So, I will take that as an input called message. But the thing is, just to avoid confusion or to actually impart a specific concept, I will not call it message because I already called it message in the argument of the function. I want you to understand that these names do not have to match. You can call it whatever. So we can call it text, and we can call the key offset. Let's just have different names. Okay. And then, so we take the text input as a message to be encrypted. And then once that is done, then we are going to call the encrypt function using those two things that we have just taken. So text and offset. And we are going to assign it to a variable called secret message. Now, observe that what we returned was called secret, and what we're assigning it to is called secret message. So these namings don't have to match at all. All right. So once, and also you see that we are passing the two values text and offset. These two names do not match with message and key, but as long as the ordering is fine, you're good. All right. So whatever you pass as the first argument will be assigned to message in the encrypt function, and whatever you pass as the second argument will be assigned as the second argument in the encrypt function. All right, so that was something very important today. Now that everything is set up, I think it's a good chance to run this. All right, so let's go ahead, run module. Oh, there are no errors yet. Okay, so the message to be encrypted, we want to use the same one as here. Let's just to make sure that we're working, it's working fine. So hello world exclamation. So let's do, whoops. So let's do hello world exclamation. So every one of these things matter, like the capitalization. And let's hit enter. Encryption key, let's give it 10. And say, well, it looks similar, right? As this. Actually, it is exactly the same. Okay, now remember what I said, like how we can kind of decrypt this message using a negative offset. So why don't we copy this? Copy this. And recall that we have used the encryption key 10. Now, the way we want to decrypt is we're going to use a negative offset. And if that works, gives us back the message we initially had set, then we will be fine. Okay, so let's give the message as the output of the last run, which is this. Now, the integer encryption key used to be 10. Now let's put in -10. Hit enter. And look, we just got back what we had initially said. So hello world. So our program works. So that was it. But let's just go through one alternative way of iterating through this, okay? So we did the characters as a sequence. So instead of doing this, you can do something else also. Instead of writing the for loop like this, we could have done for, let's say, I in range, the length of the actual message, and we called it message, right? Yes, the input string was called message. And then now we don't actually have the character yet, but we can assign that in x. X assign what to x would be message, and the index would be I, because it will go from 0 to the length -1, so that we go through the whole string. So this is another version of the v2, and this was v1, meaning version 1. So does this change make any difference? Let's see. Let's run it again. Let's do hello world, do 10. Oh look, it's the same. Let's copy this, run it again. Paste it, use -10, and there you go. And so we have just seen two ways of solving lab 2-1. All right, so that would be all for this week. If you have any follow-up questions, feel free to reach out on Piazza or email, or whichever like you prefer. Thank you.